All right, cool. So we'll go ahead and get started. And I will be sharing my screen. So I think I need to request screen sharing. Okay, there we go. Yeah. Just kind of making, okay, there we go. Can y'all see that pretty good?
Yep.
Okay,
Right.
cool.
Perfect.
All right, yeah, so this is my intro. I'm Nader. I'm a developer relations engineer at Edge and Node. And basically developer relations means that I write documentation and do blog posts and videos and speak at conferences and stuff like that, mainly helping developers, understand how to write the code to build out the different APIs and stuff using our technology. And the main protocol that I work with is the Graph protocol. It's listed on all the major exchanges, but it's also used by a lot of the major dApps in the community and the ecosystem. And essentially, it allows developers to build APIs, which are what you need to build out web and mobile applications using blockchain data. So the reason that it exists is that when you think about a traditional database, like something that you might run in AWS, or you might run, in your own living room if you have a server, any database at all. It could be a SQL database or it could be a NoSQL database. Typically, these databases are optimized for both reads and writes. They allow you to performantly save data, but as well as performantly read data. And these databases are typically like really highly scalable. So for instance, DynamoDB can handle billions of operations per minute and millions of operations per second often. Whereas blockchains, because of the nature of the technology, are limited in their write operations. So you typically hear technology around blockchains focused, and the discussions focused on how many transactions per second a blockchain can handle, the cost per transaction, and the latency per transaction. So all the blockchains are focused on this write operation of like writing data and doing it in a manner that allows for some consensus mechanism to come to some agreement. So Ethereum is like 35 transactions per second for now, and it's going to go up, of course, in the future. Then you have Solana at 100,000. You have Avalanche in the range of like 5,000. So like all these are focused on write operations, but the problem is like once you have all this data written, it's actually extremely hard to read the data. So unlike a typical database that is optimized for both reading and writing, the only thing people care about with blockchains is writing. To read the data, you have basically these blocks of data that are written over the course of days, weeks, months, years, whatever. So one block is written this minute, and then the next block is written another minute. So if you want to say, I want to get a query like something a Twitter might offer, so I want to look at this person and I want to get all of their friends, and then I want to look at certain tweets. Maybe I do an advanced search in the Twitter thing, and I want to find tweets from this person that mention this word, or I want to get any type of information at all. Is actually almost impossible to query directly from the blockchain. So what developers have been doing in the past is they basically build out a database, and then they get all this information and they save it in the database, right? And then they create an API layer, and then you basically rebuilt like a typical REST API or whatever that you might have in the Web 2 world. The problem with this, though, is that any developer that wants to build an app now has to go and basically create all this infrastructure themselves, and it's very complex. You have to understand how blockchains work. You have to create a lot of backend code for all of the data that you want, when you write your initial deployment, but you also need to keep updating that. So if you have any changes, you have to kind of like keep up with all those changes. And then one of the big things around blockchain data is that it's decentralized. And when you build all of this infrastructure and centralize it again, then that data can no longer be trusted, in the sense of how like blockchain developers and people in Web3, think of trusted data. You've now centralized it, so it's no longer coming from this source of truth. It's now centralized. So you kind of bring all of these things that kind of are not what you want for the most part for your API. So subgraphs basically allow developers to write these configurations, deploy them to a decentralized network of nodes, just like how Ethereum and Bitcoin and any other decentralized network has these nodes running that run code. People are able to deploy these APIs to these nodes, and the API description allows the node to say, okay, I want to go and I want to save all of this information. I want to do this indexing, but we want to distribute it across an entire network. And then anytime someone reads that data, it's coming from one of those nodes, and all of those nodes are basically serving the same data. So you no longer have a single point of failure. And we also have some mechanisms built in around trying to make sure that the data that is being served is actually the correct data, and it is the right data. So like we have a lot of mechanisms in place around how to make that happen. Incentives like economic incentives for the indexers to do that. So basically, instead of having to read the data directly from the blockchain, we now have this indexer. And an indexer basically, if we want to kind of compare it to something in the Web 2 world, or maybe in the world that you've experienced in the past, think of a search engine. When you have a search engine, you basically are being able to like use this interface to query for data, and it kind of gives you that data back. But what if we didn't have a search engine? We end up having all of this information on all these millions or tens of millions of websites, and it's basically impossible to know what all that data is. So what Google basically does is it basically crawls all these websites, it looks for the information, it saves it in a database, and then it exposes it in an API and a front-end application that allows someone to query it. Another good analogy, I think, is a library, where you basically have millions of books, probably, or thousands of books. And if you walk in, it's impossible to know without some type of organization which book is which. So you have maybe a Dewey Decimal System, and the Dewey Decimal System allows you to look up and say, okay, I want to find this book, and they tell you exactly where it is. And then when you want to query for that book, you know exactly where to go. So basically, a subgraph sits in between the smart contract layer and the UI layer, and it provides this index and querying layer for applications. And when someone deploys a subgraph, which is the API, it's now served from a decentralized network of nodes. And anytime someone queries for that data, it can be served up from any of these nodes, typically from the closest edge location. So if someone is in South Africa, or if someone's in Asia, or someone's in the United States, it's going to be served from the closest indexer that is running that API. So you now have this data being served from multiple places. And the way that the network works is that it's secured and run by the Graph network. And the Graph network has a few different ways that people can participate in the network using Graph tokens, or GRT. And that is the crypto that you might see being sold on an exchange. But people can actually use this and have utility by using it within the network. So let's say you have 10,000 GRT. You can use it either as an indexer, you can use it as a curator, or you can use it as a delegator. So let's talk about like what the differences are between there. An indexer is basically a infrastructure engineer, typically, or a software developer that wants to run one of these nodes, and they are running an indexing node. So they basically set aside like a server, they deploy some open source software to that server, and they're now running an indexer that allows other developers to deploy APIs to, and then that API will be served from that indexer. And that indexer will basically make money in a couple of different ways. They'll make money from the query fees that are returned from the people paying for that API, but they're also going to get a share of something that is called inflation for the entire network. So we basically issue tokens to the network to be shared between people running the infrastructure. So like, even if you're not getting as much as you maybe want from indexer fees that day, you might get some share of the the entire inflation for that day. You also have curators. So curators are people that can basically look at an API or a subgraph and say, this looks like it's going to be a good subgraph, so I want to basically curate on it. So they take their tokens and they stake those tokens with that curator, or they deposit them with that curator, with that subgraph, and they become a curator, I guess you could say better. And they will earn a portion of the query fees as well. And so if someone deploys like a new API and you're like, oh, that looks pretty good, maybe they deployed like an API for SushiSwap or for some new decentralized exchange or something like that, then you can basically deposit money or deposit GRT into that subgraph and earn a portion of those. And whenever you want to pull out, then you can actually pull your GRT back out as well. Subgraph developers are kind of the what I'm going to be demonstrating today. They're just software developers that build these APIs. And then there's delegators. And delegators probably have the most, I would say, the easiest way to kind of interact with the network with the least risk. So instead of running your own indexer, you can actually be a delegator and you can say, oh, I have some GRT. I want to put my GRT with this indexer, and you will share in a portion of the rewards that that indexer makes. So that's a really interesting way to kind of participate in the network as well. So some of the protocols being used by, some of the protocols using the graph are pull together, live peer, foundation. There's Aave, there's Uniswap, SushiSwap, a lot of these big DeFi exchanges and stuff, a lot of NFT marketplaces, a lot of DAOs and stuff are using the graph. So what does the code look like? We're going to walk through like how to build one, but essentially you're given a GraphQL endpoint once you deploy an API. And using this GraphQL endpoint, you can basically write queries to it from any front-end application or mobile application, or really any application. And instead of an HTTP endpoint like in REST, you're instead given a GraphQL URL, and then you have to basically send some type of query along with that operation, which is basically a GraphQL query, but under the hood, it's calling an HTTP post operation. And you're basically posting with the query. And from there, it just works like any asynchronous operation where you kind of get some information back and it will be returned to you. And then you can, render that information to your front end. And I'm going to kind of like build out an API that is an NFT marketplace API. And then we're going to kind of like show how that data looks and use it ourselves. So first of all, I'm going to go to the Graph website and show you, this is kind of like what the website looks like. And you can kind of go to explore subgraphs here and you can get a good idea around some of the subgraphs that are out there. So let's say we want to do SushiSwap, which is an exchange. And this kind of shows you how much GRT is being used. It shows you the indexers, it shows you people that are curating on it, and how much they've signaled. No idea why people are signaling like, some small amounts. It seems like it would be. You have people like signaling everything from 0 to 183,000 GRT. You have a playground here where you can actually run queries. So a good query might be for, let me refresh that for some reason. It's not showing up. There we go. So a query might be for something like, in this case, it might be like tokens. And then we might want to say we want to only get the first like 5 or something like that. And a token has an ID, has a name, has a symbol, and has I guess total supply. These all seem like interesting things. So we can now just basically run this GraphQL query, and it's going to basically hit an indexer, get that data, and then return it. And usually it's a lot faster than this, so I'm not sure what's going on. There we go. So here we see that we have like this chi whatever token, true USD token. So yeah, all this stuff came back, and you can kind of see all of the different data that you can get from this. And you can even do like relational data. So you can say, I want to get the token, and this might have some type of relational data like base pairs. So you might want to say the base pairs. This would have its own, ID or something like that. So that's kind of an overview of what the actual API looks like. And what I want to walk through is how to actually build one. So to do that, I'm just going to kind of like go through how this looks. I think I made a folder for this. All right, cool. So basically what we want to do is build out an NFT API for Zora, which is a NFT exchange. We want to basically say, okay, if we wanted to build out this same app and we wanted this data, how could we get that data? Because we can't just read it directly from the blockchain. We can't like render this type of nice user interface because we need all this information, and we need it queryable so we can do filtering and all types of other stuff. So we want to build out an API, and we want to kind of show this exact same data. So the way that we would do that is like, we're going to start by going to our command line, and we're going to basically use the graph CLI. So you could just say npm install -g, and then you can look at the graph CLI on GitHub, and it kind of shows you this command. It's just like a single command, fairly easy to do. Let's see here, it looks something like this. I already have it installed. So once you install it, you can just say graph, and it should show you some commands. So I'm on graph CLI version 0.22. So now that we have the graph CLI installed, we can go ahead and go to the graph dashboard, and we can go here to subgraph studio. And this is kind of where developers will go to create a new subgraph. And here I can create a new subgraph, and I will call this blockchain dev DC. And now we have our shell for our API. And this gives you like information, like you can set the categories, you can set the metadata, like the description and the source code. It also kind of gives you a little bit of information around how you might write the code to deploy this. There's also a blog post I would recommend if you want to kind of like write all this code yourself. It's on the Graph blog called Building Subgraphs with Subgraph Studio. And I'll probably share that later. But now that we have this, we can, we're going to be using the subgraph slug and the deploy key in just a moment. But we can basically now go to our command line, and we can say graph init. And this is how you create a new subgraph. And we can now start putting in some metadata. So the first thing that we want to do is we want to specify from which contract that we want to deploy this API, because basically we want to say the Zora smart contract is the contract we're interested in. So if we go to like Etherscan, and I paste in the contract address, which is actually available on their website, you can see that we have like a look at what's going on. We have the transactions. If we go to the contract, you'll see that we have the code there, and we also have the ABI down here, I think. Yeah, there's the ABI. So we have everything we need to kind of get a good idea of what's going on. But we can basically just use this contract address and give it to the CLI, and the CLI is going to pull down all the information that we need. So all we have to do is just say from contract and paste in I'm not done yet. Okay, there we go. And I want to add a few more flags in. In addition to the contract, I want to say index events. And saying index events will basically look within the smart contract itself, and it will look for any functions or any events that are fired. So like in Solidity, you can basically say emit a certain event. You can define events. So anytime someone emits an event, we're going to be indexing that event, and we're going to be able to basically intercept that data and save it in our API. We also want to define for the studio, because we have two types of ways that you can deploy to the graph. We have a centralized service and decentralized network. So we're doing the decentralized network, and you can kind of use either. It's up to you. The other thing we want to specify is the contract, because a lot of contract addresses have multiple contracts deployed to them. So for instance, I think this contract has a marketplace and a token. And the thing that we're going to be focusing on in this workshop is basically the token. So I can basically say contract name and then just say token. And from here, we should be able to go ahead and scaffold out this code that we can use. So for the subgraph slug, I can just go here and copy the slug from our UI here. For the directory, I can just now accept all of these defaults, which should be fine for me. We can choose which network we want to index. So we have mainnet, of course, but we also have Matic, which is Polygon. We have Phantom, we have Avalanche, we have Celo, we have Arbitrum. We have a lot of, I think we even have Optimism. We have all these Ethereum networks, or EVM networks, I guess you could say. So we have mainnet, we have our contract address, we have our token, and now the CLI should go ahead and create some code for us that we can start using. I'm going to go ahead and change into this new directory and open this in my text editor while that's being installed. All right, so we have our code generated for us by the CLI. And this is kind of like a boilerplate subgraph, I guess you could say. And we need to kind of make three main updates. We need to update the data model, because for us to create an API for something like this, we basically need to describe like which data needs to be saved. So for us, it makes a lot of sense to save the token, right? Because we have a token contract, we have an NFT. So like, let's save that NFT and we're going to call it token. The other thing that we might do that's kind of interesting is like, because we also have the information about the person purchasing the token, we might also create a user. So in doing that, we can create a relationship between tokens and users, and we can do interesting stuff like querying tokens in their user metadata and vice versa. We can query for users and their tokens. So those are the two pieces of data that we want to save. And in a subgraph, we're using GraphQL, and therefore we can use a GraphQL schema to describe our data. And a GraphQL schema is really essentially kind of like if you've ever used any typed language and you've defined a struct or an object or something like that. A GraphQL schema is kind of just like that, where we're going to have like a type, and then the type is going to have fields, and the fields are going to have their own type. Or maybe, I guess another way to explain it might be like where if you have a class and the class has different fields or something like that. So here we're going to use two different types. We're going to have a token type, and we're going to have a user type. The token type has all of the different metadata that we want to save. So for an NFT, the two things that you're going to probably want to be made available are the content URI and the metadata URI or something like that. They're usually called something like this though. So the content URI is going to be the actual image itself, or the video or whatever that is. And then the metadata URI is going to be typically a JSON object that has the information about the token. So the content URI might be in the metadata URI, but also the metadata URI would also have information like the token name, maybe the description, and even something like the artist information as well. And then we also have the created at timestamp just to kind of keep up with when these tokens were minted. And we have a couple of pieces of, we have a couple of fields for the creator and the owner, and these are going to be the user fields. So we're just, saving metadata on the token, and then we're basically creating a relationship between the token and the user. So I can save that. The next thing we want to open is the subgraph.yaml. And this is a lot of code. So I'm going to go ahead and delete some of this, because really we only need parts of it. Just to kind of make it a little like cleaner. So here is, this is, I guess, 27 line of code. And this kind of makes up all of the main configuration for the subgraph. And if you've ever used anything like infrastructure as code on AWS, or if you ever use any like YAML, I guess, in general, this might look familiar, I guess you could say. But basically, we are going to be describing to the indexer like what information needs to be saved and how it needs to be saved. So the indexer will basically read this file, and it's going to look through these data sources, and it's going to say, okay, well, we have a token that we want to index. This is the address that it's coming from. This is the ABI that was pulled down by the CLI token.json. We have the entities that need to be saved here. So the entities are going to match whatever we've written in our GraphQL schema. So we have a token and a user. So we can just say token and user. We also have our event handlers. And this is probably the most interesting and maybe even complex part for someone coming new to Ethereum. Because in a database, you just have that data there saved within the actual contract. I mean, within the database itself. But in Ethereum, you typically have two different ways that you can get data out of the contract, or out of the, I guess you could say out of the blockchain, the contract for that chain, or on that chain. So the two ways that you can typically do, you can read information directly from it at a certain point in time, or you can get information out of the functions and the event parameters. So for instance, if someone mints a new token, you typically have an ERC 721 contract for an NFT that fires a transfer event. And the transfer event has information about the token itself, as well as the buyer and the seller, or the original owner, and then where it's being transferred to. So when someone mints a token, we are going to be intercepting that transfer event, and we're going to be calling a function in our own code here to handle that. So this right here is where all that action is happening. So when someone either mints or transfers a token, we're going to be listening for the transfer event, and then we're going to call handle transfer. And the transfer event is receiving the three pieces of information here, an address from, an address to, and then a token ID. And then we're going to be invoking this function, passing in the address, and the token ID as well. The only other two events that we're going to be handling here are going to be when someone updates the token URI or the metadata URI. So if someone changes some information about the token, we can also intercept that event and update it as well. For a immutable contract, you wouldn't even have these. This would be like the only function you would have to deal with. All right, so we have all of that. The other thing we might want to do would be to set something called a start block, because when we deploy this subgraph, it's going to look and find this address from any block that's been written since the beginning of time. So since Ethereum was launched, it's going to actually start there. But in reality, we know when the first transaction happened, because it happened at a certain point in time. We can look it up in Etherscan, And we can just tell the indexer to not start from the beginning of time, instead start from like this block right here and then go forward. This way it's a lot faster and it does a lot less work. So that's it. We basically have all of the code we need written for the subgraph configuration. The only thing we need to deal with now are going to be these three functions here. We want to handle the transfer, we want to handle the token URI updated, and we want to handle the metadata URI updated. So to do that, we can go into our code where we're going to be handling that. And you see that here that we have the file defined as src/mapping.ts. So if I go there and open this, you'll see that we have a bunch of boilerplate code that we can just delete everything. And here's where we're going to start writing some code. So the two things that you're going to be doing in the mapping are going to be talking to the Ethereum network, and you're also going to be talking to the local node or the node itself that is saving this information. So you need to basically have APIs to talk to both the Ethereum network as well as the local or the graph node. So in order to do that, of course, you could use some of your own custom code, but we've actually created some open source tools and libraries called GraphTS, which is Graph TypeScript, that give you a bunch of helpers to do that. And in addition to that, we can even use the Graph CLI to actually look at our schema and automatically generate a bunch of that code for us. So what I can basically do is go to my CLI, and since we've made updates to the GraphQL schema, I can now run graph codegen. And this should inspect our GraphQL schema and then generate a bunch of code for us locally. So now we should have that code available now in this generated folder. So what I'm basically going to do now is go ahead and import some of that code. We're going to be importing, the main thing here is going to be the token contract and the transfer contract. And then we're also going to be importing the events for type safety. But I guess the two things here is going to be, this is going to be where we're going to be interacting with the actual smart contract itself. And then these two things are going to be basically classes and functions that allow us to talk to the graph node. So for instance, once we save a token to the graph node, let's say we need that token later, we can actually read it again. So that's kind of how that works. So the first two functions that we're going to write are going to be for the handling of the metadata and token URI updates. So we can basically have two functions, one for handling the token URI update and one for handling the metadata URI update. And I'm not going to go through both of them, so I'll go through one of them because they're both essentially doing the same thing. What we first do is we go ahead and first try to load the token. And calling token.load is going to be using this token class, and we're going to be calling here the graph node. And we're going to try to go ahead and read the current token for that ID. We first then check to see if that token does not exist. It's basically a null check to make sure we're not trying to save a null token. And if there is no token, we just return from the function and we don't do anything. If there is a token, we just update the content URI with the URI being passed into the event. And then we just save it back to the node. So like this function is going to be fired for existing tokens, and as well as this. This is going to be updating the token URI, and this is going to be updating the metadata URI. So those are kind of like really simple functions. The main function though that I would say that's a little more complex is going to be the handle transfer function. And this is going to be the function that basically either saves the token when it's minted or updates the token when someone transfers it between two parties. So we do similar thing here where we first try to load the token. And if the token does not exist, that means we need to go ahead and create it. And the way that we do that is we basically create a new token by calling new token, passing in the ID. We then start adding the different fields. So here we're creating a token with a creator field, a token ID field, and a created at timestamp field. We then go ahead and call out to the Ethereum network, and we try to get the metadata for that token because we don't have it in the event. The event only holds those 3 pieces of information, the 2 addresses and the token ID. So if we want to get the token metadata, we need to call out to the actual contract. So we're doing that here, and we're updating the metadata, the content URI and the metadata URI. We then also update the token owner, and we do that outside of that because regardless if this token existed before or not, we still need to set the owner. And then we save the token back to the node. And then we do the same thing for user, like with a null check. We see if the user does not exist. And if they don't, we go ahead and create the user. And the user really only has the address associated with them. There's really no other metadata except for the tokens that are associated with them. I know that was a lot, so but we're done now. So with that, we should be able to go ahead and test this out and deploy it. So what we basically can do now is go to our subgraph here, and I can go ahead and copy this deploy key to my clipboard, and I can say graph auth -- studio, and it should ask me for my deploy key. And now we should have our local deploy key set for authorization. And now we should be able to go ahead and copy the subgraph slug. We can say graph deploy -- studio, and then passing in the subgraph name. And then here, I'm going to go ahead and set the version is like 0.1 or something. And we hope this works. All right, looks like it deployed successfully. So it gives us the API, or gives us the endpoint where we can view our subgraph. And if I go back here and I refresh, we should see that it's syncing. So there we see that the syncing is at 87%. And we might try to go ahead and run a query. And there we go. We see that we have information coming back. So what I might want to do though is like order by created at timestamp, and then order direction. Descending, and this way we can kind of get the newest ones, but we're still only 88%. You know, it's still syncing. But we do have some information coming back, so we can copy this content URI and test it out here. And this should be an NFT. And then we should also have metadata URI here. I'll just leave that there and open this in a new window. So this is actually an HTML file. That's pretty interesting. So that's why it's kind of doing that. We might go ahead and get the next piece of content. All right, nice. If I go ahead and like run another query, we see that the ID and token ID are at 307. We're now at 657 because that means we've indexed and saved more data. So if I go here, we see that we have another NFT. So like you could basically now just take this API, use this API URL here, which it gives you, and you can start hitting it with like GraphQL queries. So I guess I'm trying to think what there's a website where you can basically test these out, but we're basically testing out here in the playground. So you know, you're given some queries by default that you can use. but you can now kind of use this and you can build out your own front end like this with existing blockchain data. And that's kind of the essence of building on these types of decentralized networks, is that you don't really need often to build out your own backend infrastructure. You can kind of plug together other people's infrastructure and build interesting experiences on top of it. One of the subgraphs I created recently is the Bored Ape Yacht Club subgraph. So if you go to Graph Explorer, we go to the Legacy Explorer, which is kind of the old one. We have this Bored Ape Yacht Club API. And here we can kind of get the all of the apes. So I think building out those types of APIs are pretty interesting. IPFS kind of sucks sometimes.
Oh, well, we have a question in the chat. Is it costing you as a developer any crypto to make those queries if outside the playground?
So you're basically given a rate limited endpoint that you can use anywhere. So, you can basically use the endpoint that's given to you either in the playground or in your front end app, but there's only a certain amount of operations you can use until you start having to pay. That's for the decentralized network. If you use the centralized service, the hosted service, like they call it the legacy service at this point, even though it's not going to be deprecating anytime soon, it's actually free. So like some of the high volume customers like Uniswap are actually still using the hosted service just because it's free, but also there are a couple of features that we don't have yet. So that's why we still have it running, because we want to make sure we continue to support all of those people. So yeah, you could basically use a subgraph for free right now indefinitely until we kind of move everything over to the network in production, Yeah, I think that's kind of about it. So yeah, if anyone has any other questions, I'd be happy to answer. I know that quite a bit.
Yeah, you said a lot, and it's really interesting. How much do you think it will cost in real life to do a query like you were doing, the types you were doing? I mean, how much do you think that would cost?
Yeah, so we look at it sort of like comparative to maybe what you might pay AWS to be querying some type of serverless API or something like that. So it really kind of depends though on the indexer market. So you basically have a market of indexers who are competing to offer the best service at the best price. But right now, like we already have a lot of developers and companies and projects using the decentralized network. I think it's like 0.0001 cent to 0.00001 cent. So I think it's like 0.301 cent to 0.401 cent right now, depending on the person. That's per query. So you could say like, 10,000 queries or maybe 100,000, 10,000 to 100,000 queries for $1 or something like that.
Cool, thank you.
Yeah, any other questions?
I was just feedback. That was great. Just reminding me of my training I'm doing right now in Solidity. So yeah, it's good to see some of that in action.
Yeah. Some of the stuff I talked about with the events and stuff was interesting to me when I was learning Solidity.
Let me ask you something, Nader, just to sort of encapsulate the whole thing, what this does. It's sort of a way to do searching using the GraphQL protocol on the Ethereum network, but via a decentralized service that people get paid for. So It's sort of like a Google, but it's not Google. It's anybody who wants to be an indexer, and then all the other roles you have, the curators. The curators just sort of put their stamp of approval on something. So it's like a way to advertise a particular.
Yeah, exactly. Like if an indexer is, going to index a subgraph, then they will typically index a subgraph that has high curation because they think that that means that it's going to be something that people are interested in using because people have put their money where their mouth is essentially and done that. So it's kind of like a marketplace that kind of, you know, is financially incentivized by all these different participants.
So it's sort of a decentralized search capability.
Yeah, a lot of people call it the Google of blockchains,
Mhm.
and I think that's a fair comparison.
Mhm.
And like we are a core infrastructure play, so like the idea here would be like if the market grows by 10x or 100x, then by default we should be also growing because a lot of the market is using us, and there isn't an easy way to do this. Like again, it's like really, if I personally wanted to build out one of these indexers, I could probably do it. I'm a software engineer of like 10 years or something, but it wouldn't be easy,
Mhm.
you know, but like I can write a subgraph in like 30 minutes or something. So like it
Mhm.
kind of just reduces the complexity.
It's really interesting. Really interesting. I could see how this in the future could become huge. I mean, just like Google when it started, well, there were a lot of search engines at the time, but Google was a fast one. I mean, well, or look at the first search engines and, you know, everybody would, it was, you really had to have foresight to realize how important search was going to be. And maybe the same thing is for what you guys are doing. I mean, I'm not
Yeah,
sure.
I mean, we have a lot of, you know, really great engineers and stuff, but we also have a lot of firepower from our treasury. So we like just acquired 2 companies that are basically completely focused now on improving the speed and the, I would say like scalability of our existing implementation. I think we spent like $140 million on those 2 acquisitions, and they're only essentially aqua hires. So essentially we did that just to bring in their engineering teams for like 3 to 5 years, just to help continue optimizing on this.
Wow. How many people are in the company?
I'm trying to think, like, you know, we have anywhere between like 30 to 80, depending on how you define company, because a lot of the people that we work with are not really employees. They're just like grantees,
Sure.
or they're like part of these like aqua hire type of deals that are like temporarily here for a few years.
Yes, one question I had is when, I guess, modeling a subgraph from a existing contract, how do you kind of start that modeling? Like for this one, we had the token and user, but there could be so many other type of things in the contract. How do you kind of go about setting up that subgraph YAML?
Yeah, for me, I kind of look in the contract and I look for any types of variables that are created. So if someone creates like a variable to store something, that is a signal to me that, okay, this might be something I want to save. What people are doing now, though, they're actually building their smart contracts specifically for a subgraph, because when you store information in a smart contract, it costs gas money. And of course, Ethereum kind of has this problem right now where gas is expensive. So like, what if you just didn't save anything and you just called events within the contract, therefore not needing to actually save anything? And then we just are able to index those events. So I think like a good way to think about it, to think about it, yeah, would be to like create structs and store your data in these structs, and that would be like an entity, so like a token struct or user struct, and then to be sure that you use events very, very heavily, because like anything that's thrown into event can be indexed. You can also index functions and blocks as well. It's just a lot slower from what I understand. So like if someone just calls a function that's not an event, you can also index that.
Awesome. I think this was very helpful. I'll stop recording now.